A very good morning to all the lovely students. I hope you are doing well, and within next 1 week you have your major day, the final day NEET exam, and I hope you have prepared well all this last year or last 2 years and you are going to crack it for 100% sure. Okay, so just to help you with little bit of your last minute preparation, today this is me, Anirudh Mehta. I'll be starting with your 100 important questions. I have taken actually more than 100 questions here from organic chemistry part of both 11th and 12th class NEET chemistry. I've taken many previous year questions, similar to previous year questions, and all the questions are going to be NEET level, nothing too much difficult and nothing too much easy also as compared to NEET. Okay, so let us start with our first question. We'll start with the GOC, General Organic Chemistry, which is chapter 1 of class 11th. Okay, so starting with the nomenclature part. As you can see here, these are the functional groups present here, ketone and alcohol. We know ketone is more important functional group for us. So ketone should get the lowest number. So let's choose the parent chain first. Parent chain must take this carbon. So 1, 2, 3, 4, 5, maximum 5 carbons in the parent chain I can take. Numbering must start in such a way that our functional group carbonyl should get the lowest number. From here 1, 2, 3 it is getting 3. From here 1, 2, 3 it is getting 3. Both sides is getting same number. So we should start from where the substituent comes early. From here substituent is coming on second number. Here substituent is coming on very first number only. So I'll start numbering from the right hand side. 1, 2, 3, 4, 5. So it's a methyl on fourth number and hydroxy on the first number. And because H is before M, we'll start with 1. So 1 hydroxy, 4 methyl, 3 pentanone. 3 pentanone. Okay, that's a simple one. Correct. Moving to the next one. Question is, which of the following is true regarding hyperconjugation? You know, hyperconjugation is a no bond resonance. Okay, it takes place in carbocation, takes place in alkenes, it takes place in free radicals. Like inductive effect, it involves donation of electron through S means sigma bonds. There is no donation of electron in the inductive effect. In inductive effect, there is no donation of electron. There is just partial shifting of electrons of sigma bond. Hyperconjugation involves overlapping of filled orbital with empty p orbital of the carbocation. This is absolutely correct. So when you want to do hyperconjugation, the condition for hyperconjugation is availability of alpha hydrogen next to a sp2 carbon. So this is a sp2 carbon here. Instead of a sp2 carbon as a alkene, you could have taken here a carbocation, something like this. So carbocation has an empty p orbital. In this p orbital, the alpha hydrogen sigma will overlap. So this sigma orbital overlaps with the empty p orbital. So it is absolutely correct. Like resonance, it involves displacement of pi or lone pair of electrons to the carbon bearing positive charge. No. Pi electrons do not move to the carbocation. The sigma electrons move to the carbocation. So this is absolutely incorrect. It involves delocalization of sigma and pi electrons. This is absolutely correct for a alkene. Sigma electrons delocalize with the pi electrons. So 2 and 4 are correct. Directly we can choose option A. Option A. Delocalization of sigma and pi electrons also are here in the case of alkenes. So if I take a propene which looks like this, here this sigma, you should say like this to yourself, sigma become pi, pi become minus. This is hyperconjugation. So sigma electrons are actually delocalizing with pi electrons. Next one, moving to the next question. It says fractional distillation. When do you use distillation? Distillation is a method of separation of 2-3 organic compounds with the principle of difference in boiling points. So when boiling point difference is large enough, you can do simple distillation. And when boiling point difference is not too large, but it is a less boiling point difference, then you use fractional distillation. So there is a large difference? No. There is a small difference. This is correct. Option B. Option B. If boiling points are same, you cannot even use distillation. Okay. If boiling points are same, you cannot even use distillation. So B option is correct here. Next one is a numerical from Dumas method. Directly learn the formulas of Dumas method. Dumas method formula is going to be percentage of nitrogen equal to 28 by 22400 into volume of nitrogen at STP obtained by weight of organic compound into 100. This formula can be written as a very simple one. 0000 will cancel out and it will exactly go 8 times. So it is 1 by 8 into volume of nitrogen by weight of organic compound. This is the formula of percentage of nitrogen. Just we'll be using this formula. Now, be very careful that nitrogen's volume must be given at STP. If it is not given at STP, first convert it to STP volume. Okay. For example, here if I see organic compound 0.25 gram gave 40 ml of nitrogen at 300 Kelvin and 725 pressure. So this is not STP. STP is 273 Kelvin and STP is 760 mm pressure. Aqueous tension is 25. What is this aqueous tension? Actually, whenever nitrogen is collected over the surface of water, the pressure is not only pressure of nitrogen gas, but it is a pressure of nitrogen gas plus pressure of water vapor. So first thing you do is find out the pressure of dry nitrogen gas. So pressure of dry nitrogen gas is the total pressure given 725 minus the aqueous tension. So aqueous tension is pressure of water vapor. So which comes out to be 700 mm. This is the pressure given to you. The volume given to you is, let's call it V1. The volume given is V1, which is 40 ml, and the temperature given is T1, which is 300 Kelvin. This is not the volume we can use in our final formula. First, we have to convert this volume into STP volume. And how to do that? By using the ideal gas equation P1 V1 by T1 equal to P2 V2 by T2. P2 V2 and T2 are my STP condition. P1 V1 T1 are the given conditions. So I'll just find the value of V2 from here and I'll put into the formula. So from here V2 comes out to be P1 V1 by T1 into T2 by P2. Okay, I'll just put the values directly. P1 V1 by T1, P1 is 700, V1 is 40 by T1, which is 300. T2 will go up 273 Kelvin STP and P2 will come down 760 mm, which is 180 mm. This volume needs to go in this formula. This volume needs to go in this formula. So percentage of nitrogen comes out to be 1 by 8 into this whole value 700, 40, 273, at the bottom 300, 760 and weight of organic compound, which is going to be 0.25. This is the percentage of nitrogen. Calculations are going to be little intensive here, will take little bit time, but do the calculation part yourself and you will get your answer. Okay, so that's the next type of questions from GOC, General Organic Chemistry, which is from the quantitative analysis. Okay, I hope it is clear to everyone. Going to the next one, qualitative analysis. All the reactions which you have studied in your class 11th of the practical organic chemistry, you must remember them. All their colors you must remember and the reagents you must remember. Question is now sodium nitroprusside. This is nitroprusside test we do for sulfur. So whenever sulfur is there in your organic compound, once you prepare Lazane's extract, sulfur comes out as sodium sulfide, Na2S. And then Na2S reacts with nitroprusside to give you a purple color solution of thionitroprusside, which is Na4 FeCN5NOS. This is violet or purple color. Violet or purple color. Moving to the next one. Which of the following compounds does not show Lazine test for nitrogen? Very important. If you want Lazine test for nitrogen, you want to create sodium cyanide. For sodium cyanide, both carbon and nitrogen are required in the organic compound. So urea has carbon and nitrogen, there is no problem, it will give. Hydrazine, NH2, there is no carbon here. So if an assertion reason type question comes that hydrazine does not give positive, positive ferrocyanide test after making a Lazine's extract, it is because there is no carbon inside it. So reason will be hydrazine does not contain both carbon and nitrogen. Okay, it contains only nitrogen. Phenylhydrazine obviously contains carbon and hydrogen. Okay, phenylhydrazine contains both carbon and hydrogen. Phenylhydrazine is a hydrazine with a benzene ring attached. NH2, on this side, one benzene ring. So phenylhydrazine. It contains, and azobenzene also is a compound containing carbon and nitrogen both. Okay. Next one. The most suitable method for separation of 1:1 mixture of ortho-para-nitrophenol. Very important, it's a PYQ as well. Beta, you should remember that ortho-nitrophenol is steam volatile because of intramolecular hydrogen bonding. One of the important question, it is steam volatile. But para-nitrophenol is not steam volatile because there is intermolecular hydrogen bonding. When you take para-nitrophenol, there is actually intermolecular hydrogen bonding. So two molecules or more molecules are attached like this to with each other. Hence, it will not be very volatile. Okay, it is difficult to separate these molecules. Yes, so answer will be C. Steam distillation is the method we use for them. One of the important question. Yes, Najib. Okay, so this is the one. Moving to the next one. In Geldahl's method, nitrogen is estimated as ammonia. Ammonia will come out, that ammonia will react with H2SO4, and from there you find the percentage of nitrogen. Okay, so in Dumas method, nitrogen is estimated as N2 gas. In Geldahl's, it is estimated as ammonia gas. Okay, this is an important concept. Next one. The question is, which of the following show optical activity, optically active? Remember it from now on, as a trick you can learn and remember it. Whenever you get biphenyls like this, these biphenyls are sometimes planar like this. All carbons are sp2, so they will remain in the same plane, and they can rotate their sigma bond, this sigma bond, and they can go out of plane something like this. Let's say one is on this board, other ring is going inside and outside of the board, something like this. Okay, you can think of it like this ring is lying like this ring is standing like this, standing ring and lying ring. Yes, so for this the condition is simple. On both the rings, 4 substituents should be there on the ortho and para position. 4 substituents should be there at ortho and para position. Oh, sorry, ortho position. So this ortho position must be filled, this ortho position must be filled, and on one benzene ring, the two groups must be different. Means here should be A, then here should not be A. These two must be different, and these two must be different. It may be A and B. There may be P and Q, R and S, like that. So these two must not be same, these two must not be same. So option 1 will not be chosen because there is hydrogen. Hydrogen must not be present. All 4 groups should be not hydrogen. Here also hydrogen is present, that is the problem. Here also hydrogens are present and groups are also same. Here the two groups are different, here the two groups are different. All 4 positions are substituted as well. So it will not have any plane of symmetry and it will show you optical activity. Okay, so this is the one. Moving to the next one. The number of asymmetric carbons created and number of possible stereoisomers when benzyl is reduced by LiAlH4. So let's see the question. Phenyl CO-CO-phenyl. This is the dicarbonyl we are starting with. Phenyl CO-CO-phenyl. And we are reducing it with LiAlH4. You know, LiAlH4 reduces carbonyl compounds to alcohol. So since it's a ketone, it is going to give you a secondary alcohol. This will become a secondary alcohol. This will also become a secondary alcohol. So first thing is how many number of asymmetric or chiral carbons. This carbon is chiral attached to 4 different groups. This carbon is chiral attached to 4 different groups. So chiral carbons are 2. We generally call it as N. N is 2. Now when N is 2, total number of stereoisomers, remember the formula, stereoisomers. To get stereoisomers, you need to check whether molecule is symmetrical or asymmetrical. If the molecule is asymmetrical, means you cannot cut it into 2 equal halves. I can see that I can cut it into 2 equal halves. So it is a symmetrical one. If it is asymmetrical, then you say 2 ki power n, means 2 ki power 2, 4. But since this is symmetrical, we will not use this formula because one of the compound will come out to be a meso compound which will be optically inactive and it will not have a mirror image. Okay, so total 4 will not come. You remember the formula directly. It will be 2 to the power n minus 1 plus 2 to the power n by 2 minus 1. N should be even number here. For NEET, this is sufficient, only one example. Okay, like when you see tartaric acid is also similar example. This is tartaric acid. COOH, CHOH, CHOH, COOH. Also similar case, tartaric acid. So remember it, they will have 3 stereoisomers, 3. So 2 ki power 2 minus 1, which is 2 power 1, plus 2 ki power 2 by 2 minus 1 means 2 ki power 0, 2 plus 1, 3 isomers. 2 and 3, yes, good. Those who have answered 2 and 3 is correct. Remember this now. So when the molecule is asymmetrical, 2 ki power n directly you put. When molecule is symmetrical and even number of chiral carbons are there, 2 ki power n minus 1 plus 2 ki power n by 2 minus 1. Okay, like this you need to solve it. Next one. Some statements are given, just we have to find which all the statements are true, which are incorrect. Staggered conformation of ethane is less stable than eclipsed, not correct. Okay, staggered means completely away from each other, the hydrogens are. This is staggered. An eclipsed formation or eclipsed conformation of ethane looks like this. So staggered looks like this. It is much more stable because of no strains, no torsional strain. This is unstable due to torsional strain. So front 3 hydrogens, sigma bonds and back 3 hydrogen sigma bond, if they are directly parallel to each other, it will be unstable. So it says first one is false. Second one, eclipsed conformation of ethane is more stable. Eclipse is more stable. This is also false. Eclipse is less stable. I just told you. Eclipse is less stable. So this is also wrong. It's a false statement. Eclipse conformation is more stable. This is also false. Staggered is more stable than eclipse. That is correct because staggered conformation has no torsional strain. This is the true statement. So last one is true. So false, false, false and true. Okay, that's the one. Now let's move on to the next question. Which of the following is again the true false we have to play here again. Let's see. The number of contributing structures are more, then more is resonance energy. This is absolutely true. Anyone who shows more resonating structures will have more resonance energy. Resonance energy always brings stability, means more energy will release. So if any molecule is going for more resonance, that is better. Like for example, if I take this molecule versus this, if I take this molecule. In these cases, here only plus nothing pi, single resonance will be there. His plus nothing pi, 3 resonances are there. So this is more stable and this has more resonance energy. Energy is not inversely proportional to stability, beta. Potential energy of the molecule is inversely proportional to stability. Resonance energy is an exothermic process, means it's an exothermic energy. More resonance energy, more energy released. So if you have more resonance energy, your own energy will be less, your own potential energy will be less and you will be more stable. So more resonance energy, more stable, more resonating structures also. Next one says resonance structure have different positions of nuclei. Different positions of nuclei. Nuclei means atoms. Atoms must not change their position. In resonating structures, only the pi electrons and lone pairs, they can change their position. Nuclei means atoms and sigma bonds must remain at their original position. There should not be no change. So that's a false. Energy of actual structure of molecule, the resonance hybrid, is lower. That is absolutely correct. This is true. So if I take benzene, this is the hypothetical structure of benzene. This is another hypothetical structure of benzene. Benzene is neither this nor this. This is the real structure of benzene. So real structure of benzene is more stable and the difference between the two is called as resonance energy. Okay, the difference between the most stable canonical form and the resonance hybrid. This is resonance hybrid. So you take the bottommost canonical form. In this case, both are bottom only. Bottommost canonical form and the resonance hybrid. Their difference is called as resonance energy. So true, false, true. True, false, true. Okay, keep remembering these things. Actual structure means resonance hybrid. It always has lower energy as compared to our imaginary structures or canonical forms. Next one, which will undergo nucleophilic substitution readily. Nucleophilic substitution, first of all, is very difficult for haloarenes because they have partial double bond character. So only one reaction you have studied in your syllabus, which was Dow's process. Okay, which was Dow's process. So when you reacted with NaOH, high temperature, high pressure you require. Then this OH can replace this Cl by nucleophilic substitution reaction. But it is easy when electron withdrawing groups are attached. So minus M groups help in this process, you might have seen. Yes, so A is the answer, very good. Minus M groups, NO2 you can attach, CHO you can attach. So this is going to be actually easily removed because this NO2 is pulling electron from this chlorine and making it more partial positive. So attack will be easy. Another reason is there from the mechanism, which is here, you can check in the NCERT, a Mesenheimer complex gets formed and NO2 can stabilize that Mesenheimer complex. Okay. Here CH3 is donating electron, not good. Here OCH3 is also donating by plus M, not good. Here it's average, not very good reaction, not very bad reaction. So this will be somewhere in middle. So A, then D, then B and C. Next is stability of carbon ion we are checking here. Carbon ion are more stable, remember it, on sp carbon, then on sp2 carbon, then on sp3 carbon. Very important example, this is a PYQ again. So in this case, here a carbon ion is on sp RC, this is a triple bond beta, just make it a triple bond, RC triple bond C minus, sp carbon, R2C double bond CH minus, sp2 carbon. On a phenyl also is a sp2 carbon. Here is a sp3 carbon. So you can easily see here, fourth become the worst, first become the best. Fourth, first. Fourth, first. So we are confused between A and D. Now when you are confused between A and D, you can check the other carbons. Okay. On this carbon in sp2, one side is hydrogen, one side is sp2 carbon. Okay, one side is hydrogen, one side is sp2 carbon. On this carbon ion, one side is sp2 carbon, which is this one, other side is also sp2 carbon. Both side sp2 carbon, they will attract the electron by minus I effect, making it more stable. Okay, so sp2 carbons pull the electron, they are very electronegative. Both side sp2 carbon, in here only one side sp2 carbon, so this is better. So this is the best, this is second best, this is third, and this is the worst, fourth. So 1, 2, 3, 4 is the answer, A option. Good. Next one. Again carbon ions we are checking. Just draw their structure and see. Just draw their structure and see. CH3 whole thrice C negative. So methyl attacked on carbon, methyl and another methyl. 3 methyls are attached to carbon ion. Next one. 3 chlorines are attached to carbon ion. Very, very good. This type of carbon ion is super carbon ion. Very good carbon ion. Okay. Next one is a secondary carbon ion. 2 methyls are attached. And last one is a primary with a benzene ring attached. So, if I look at their stability, I need to check what is happening to the electron. If someone is pulling electron from the carbon ion, that is good for us. Remember this, whenever chlorine, sulfur, phosphorus, these things are attached to carbon ion, they have empty d orbital and they can show very good resonance, back bonding we call it. So minus nothing empty d, this minus can be donated here. So fluorines cannot do that. Chlorine, sulfur, these people can pull the electrons of carbon ion by minus m, making them very, very stable, much stable than everything else. Then here if you see, here also benzene ring is taking the electrons for resonance. Here also resonance is there, but it is not as good as back bonding. Remember it, back bonding is much better than a normal carbon-carbon resonance. Okay, chlorine will pull much better. Whereas the next two, this is a tertiary one. Tertiary is a very bad carbon ion because here 3 people are sending electron by plus I. Here 2 plus I. Here 2 plus I. So this is somewhere in the middle. Okay. So the best one is the second option. So it's the second option, B. Okay, remember it. So generally you see chlorine is a minus I effect, but here chlorine is acting like a minus M. It is very rare, but in this case you have to learn it. Carbon ion next to chlorine, very stable carbon ion. Next one. They say chlorine in vinyl chloride. Let's make vinyl chloride. Vinyl means ethynyl. This is vinyl. Vinyl chloride. This is vinyl chloride. Why is it less reactive? We can see. It is less reactive because chlorine's lone pair are going for resonance like this, and there is a partial double bond character here. There is a partial double bond character here. So by resonance, this also becomes a partial double bond. This also becomes a partial double bond. So it becomes very difficult to break this bond. Very difficult to break this bond. So it's a second option. It's the second option. CCl bond develops a partial double bond character. Same problem comes in aryl halides as well. Means chlorobenzene is also less reactive because of the same reason. All are not correct, beta. All are not correct. sp2 carbon's hydrogen is more acidic. It's a correct thing, but it does not explain our question. Okay, statement is correct, but it is not related to our question. Statement is correct, but it is not related to our question. No. If the question is chlorine in vinyl chloride is less reactive because if I say tertiary carbocation is better than primary carbocation, it doesn't mean anything, no. So it should be related to our question. Next, we'll start with the hydrocarbons. So we are done with our first chapter of organic chemistry, which is general organic chemistry, and now will be starting with the more reaction related chapters, which are hydrocarbon till amines. Okay, let's do first one. Which of the following reaction is expected to readily give a hydrocarbon product? Who will give a alkane or alkene or alkyne is the question. First reaction beta, it is Kolb's electrolysis. What happens in Kolb's electrolysis? You take 2 moles of carboxylic acid salt, remove 2 CO2 and the RR will attach together and give you alkane. RR plus 2 CO2 plus hydrogen gas at cathode plus KOH remaining, like this will be the overall reaction. So yes, it is giving us alkane, no problem at all. Next one is not in a syllabus reaction. This one is called as, Hunts-Decker reaction. For Hunts-Decker reaction, you can forget it, you can leave it also. When you react silver salt of carboxylic acid with bromine, you get RBr. So one bromine goes with R, so you get alkyl bromide, you get a CO2 gas and you get a AgBr. So this is a preparation of alkyl bromide, not alkane. Remember it. Okay, it's called as Hunts-Decker reaction. It's not very important as well. Next one is a free radical substitution beta. Free radical substitution, which gives you alkyl halides. Monoalkyl halide, dialkyl halide, tri, tetra, penta, hexa. So many products will be there as byproducts. Free radical reactions are very difficult to control. Last one is going to be your nucleophilic substitution. This is a nucleophile. So here Cl will go out and OC2H5 will attach. It is going to be a SN1 reaction because we have taken a polar protic solvent here. It is not Williamson ether synthesis. Okay, Williamson ether synthesis would have C2H5O minus Na plus here. But this is a neutral nucleophile, so it will go by SN1. First, this chlorine will go out. We will get a very stable carbocation, CH3 whole thrice C positive, and then this OC2H5 will attack it. So we will get a ether. So ether formation will happen. So answer is first option. Yes, they are good questions for NEET. Enough or not enough, we cannot say. But yes, it is enough to revise your concepts quickly. Okay, keep giving the exams, the grand test paper which are happening, then it will be sufficient. Next one. Next one says CH2 double bond CH2. So ethene we started with. Ethene mein we are adding hypochlorous acid, means HOCl. HOCl is Cl positive, OH negative. So by Markovnikov rule it will add. Since it's a symmetrical alkene, you don't have to think about Markovnikov. Any one place you add OH, any one place you add Cl. So I'm going to reach to CH2Cl, CH2OH. Now they are saying add something R into it so that this Cl also become OH. So this R should be aqueous NaOH or aqueous KOH. So what is M and what is R? This is not M, but R is correct. This is not M. This is M. Aqueous sodium bicarbonate. This also you can take because sodium bicarbonate, it is a salt of strong base and weak acid. So by hydrolysis, it will provide you NaOH in the solution. It will be a basic solution. From the yesterday's class, you could think from the ionic equilibrium that when there is a salt of strong base, weak acid, its solution is basic only. So OH minus will be available and you can do the nucleophilic substitution. Third option. Next one, let us go for now. Next one is, starting with the propyne, we are adding water. Water addition in the presence of acid and mercuric sulfate acts like a catalyst. Water will add by Markovnikov rule, where OH will go to the center and H will go to the corner, giving you a enol. And we know enols are unstable, so they undergo tautomerism to give you ketones. So acetone is the final product, acetone. So A and B they are asking. A and B is going to be, this is correct A, but this is not correct B. This is not correct. This is correct and this is correct. By chance they have given two bonds here, it's a single bond, okay. So this is a correct one. C option is correct. Yes, C is correct. Good. Is it clear to all those who are watching? Jaswant, are you all understanding? Yes or no? You can quickly like the video in case it is clear. Okay, next one. In the next question, this is a nice and little difficult question you can see here. This compound is obtained by ozonolysis of which? So there are two ways to do this question. One way is a little long way. You do the ozonolysis of all the reactants given and see which one is matching the reactant. Otherwise, you take the two carbonyls and remove their oxygens. Before ozonolysis, there was a pi bond between the two carbons where the oxygen has come now. Okay, so this oxygen and this oxygen, you just remove and put a pi bond between them. So it is carbon number 1, let's say, 2, let's say, 3, let's say, 4 and 5 and so 5-membered ring. Let us make a 5-membered ring, 1, 2, 3, 4, 5. Call it as 1, 2, 3, 4, 5. First carbon and fifth carbon have a pi bond like this. Third carbon has a methyl like this. Fifth carbon also has a methyl like this. Okay, that's all. This is the answer. So you can just check which compound this is. This is the compound, as you can see. Okay, numbering I did just to get the final answer. This is not the real numbering how you should do. So 1, 2, 3, 4, 1, 2, 3, 4. Last option is correct. Last option is correct. Okay, that's all we can do for such type of question. Now moving to the next one. In the following reaction, the major product is going to be. This is another good question where you have to do little bit of rearrangement. It is called as 1,4 addition. So whenever you see a conjugated pi bond, pi nothing pi. Now do not add HBr to one of the pi bond. You should do 1,4 addition. You should do 1,4 addition. Now how to do 1,4 addition? You can see here. You should make the pi bond run. Pi become pi, pi become minus like this. Pi become pi, pi become minus. Or you can say the other side, pi become pi, pi become minus. So two options are there. Okay. Now how the reaction is taking place, you can see here. First time we know that in electrophilic addition reaction, alkene attacks on H positive to make a carbocation. In this case, here a carbocation will be more stable. So let me attack H plus from this side. So when you attack the H plus, you get the carbocation which starts looking like this. This is the carbocation. H has attached here. Okay. Now, if you directly do addition of bromine here, you will get this answer. But don't do this, because if I do this, My alkene will be a terminal alkene. You know, terminal alkenes are not stable. They have less hyperconjugations. So what I can do is I can do a resonance. That another resonating structure will be pi nothing plus pi moves ahead, and it can go and undergo resonance and also look like this. But this alkene looks more stable than the previous alkene. So now bromide will come and attack, and you are going to get the rearranged product or 1,4 addition product like this, which is option D. Little difficult, but if you can learn this, you should remember. Okay, whenever there is conjugated pi bonds, instead of doing 1,2 addition, you should do 1,4 addition to get the major product. Next one. Who will not react with acetylene? Beta, acetylene is an acidic nature alkyne. Those alkynes which are terminal carry this hydrogen are acidic. Do they react with NaOH? Answer is no. They are not so acidic. They do react with ammoniacal silver nitrate, which is nothing but Tollens reagent, to give you a gray color precipitate which looks like this. Do they react with sodium? Yes. All these acidic people like alkynes, like alcohols, they all react with sodium. Okay, carboxylic acid, sulfonic acid, phenols, alcohols, alkynes. They react with HCl, yes, not because of their acidic nature. They will add the HCl into them by Markovnikov rule. 2 times they will add to give you dihalides. So A is what they will not react with. You can keep your notebooks with you. You can keep writing whenever you see a question. Keep writing the answer so that you have something to, revise upon after the class. Next one is another electrophilic addition question. Alkene attacks on H plus, giving you a carbocation. So whenever you get a Markovnikov addition question, never do Markovnikov addition directly. Always go with the mechanism because rearrangement is possible. So you are going to get phenyl CH2 CH positive CH3 in the first step. Now if you do a mistake, you will directly just put a Cl here and put this answer, but this is incorrect. Okay, this is incorrect because carbocations tends to rearrange. So whenever you get a carbocation, it will ask the neighbor carbon, do you want my plus? Neighbor will say yes, give me your plus, because I am a benzylic carbocation. So I will be a much better carbocation than you. So you do a hydride shift. Take a hydrogen from here and shift it here. And then Cl will come and attach here. So this is the major product, C. Yes, do the rearrangement during Markovnikov addition. Okay. So this is how we can solve this question. Next one is also a good question. Can you all answer it? Can you think and try this question? I'll give you 2 minutes. Okay, now we want to prepare this particular compound. Let us do both the reactions and see what do we get. NBS is a reagent used for allylic bromination or benzylic bromination. These are all benzylic carbon, benzylic carbon, benzylic carbon. So everywhere NBS can attack a bromine. So you will get a Br here, you will get a Br here, you will get a Br here as well. and then NaOH is going to replace all Brs with the OH. So I'm going to get a OH here also, a OH here also, and a OH here also. This is not what I'm trying to prepare. I want only one carbon to get the OH, not all the carbons. Next one, let us see. Bromination we are doing. This is electrophilic substitution reaction, ESR. It will go on ortho position of these methyls, any one ortho position I am putting it. So methyl up, methyl down, and at any one ortho position a Br I am putting. Then you are doing magnesium in dry ether, not ethane, magnesium in dry ether. This will make a Grignard reagent. So MgBr here. This CH3 as it is, this CH3 as it is. I am writing it as methyl. Then we know that when Grignard attacks on a formaldehyde, you get a primary alcohol. So from here, this minus will go and attack on this carbon. This will become OH. So finally, product that we are getting here is top methyl maintained as it is, bottom methyl maintained as it is. Here or here, anything is fine. I get CH2OH. So yes, this is our perfect product. So method 2 is the best one. Method 1 is not good. Method 2 is the best one. Method 1 is not good. Next one. Now we'll go to class 12th and start with the first chapter, haloalkanes. Haloalkanes and haloarenes. Haloalkanes and haloarenes. First question is from physical chemistry. All of you can solve it. They are saying vapor density of the compound is 23, means molar mass is 46. We know that molar mass is double of vapor density. Molar mass is double of vapor density. So molar mass is 46 gram. 46 gram, you should remember, it is ethanol. So it might be ethanol. It might be a ether. Dimethyl ether. Two options. The compound gives iodoform test, which confirms it is ethanol only. Which confirms it has to be ethanol. So we can directly put it as first option. Ethanol. Okay. Others will not match. Sir, in previous question, why hydride shift? There is benzyl, which is more stable. This is benzyl, na beta. This is not benzyl. First carbocation will come here. It is not benzyl. This is benzyl. This is benzyl. Jaswant. So after shifting, it will become benzyl. Okay. I hope it is clear. Next one. Which of the following is an example of SN2 reaction? It is a primary alkyl halide. This must be SN2 reaction. In the next one, it may be SN1 or SN2. We cannot say with 100% surety because secondary alkyl halides can undergo SN1, SN2 both. And the next one is a clearly elimination reaction. It is going to be a E1 elimination reaction, dehydration of alcohols, acidic dehydration. And the last one has to be SN1 because it is a tertiary alkyl halide. They never undergo SN2. So first is the best option. Second may be SN1, second may be SN2. Okay. Next one. Next one says, starting with this compound, a 3-iodo 2-chloromethyl benzene, we are adding NaCN. This is nucleophilic substitution, all of us know. There is a partial double bond character here, so don't attack anything here. Cn minus will replace this Cl. So I'm going to get benzene, here iodine, and here CH2, C triple bond, N. That's all. So second option. Good. Next one. Which of the following will have a mesoisomer? Meso means meso compound, means optically inactive molecule due to plane of symmetry or center of symmetry. So draw all their structure and see which is a symmetrical molecule, but it has to carry chiral carbons. 2,3-dichloropentane. This is pentane beta. This is 2,3-dichloropentane. I can't cut it into two equal halves, so it can't have a meso compound. 2,3-dichlorobutane. 2,3-dichlorobutane. Yes, this is a very good compound. You can cut it into two equal halves like this. It is a very symmetrical compound. Okay, it is a very symmetrical compound. I can draw its structure like this. CH3, CH3. Carbon with the Cl, carbon with the Cl. If I draw it like this is a meso compound. I can cut it into two equal halves. So yes, this will have 2-chlorobutane will be optically active. You can't cut it into two equal halves. There is a chiral carbon, chiral carbon, chiral carbon, chiral carbon. 2-hydroxypropanoic acid also will be optically active. You can draw it and check. Okay, going to the next one, moving to the next one, orthomethoxy bromobenzene, okay, is treated with sodamide. Orthomethoxy bromobenzene is treated with sodamide, NaNH2. This is little bit of a difficult question from a benzyne mechanism. You can see here what will happen. So what is the product form? In so whenever you take haloarenes, chlorobenzene and all, if they have electron donating group attached on the ring, then the reaction occur by benzyne mechanism. So first you do what is attack your NH2 minus on the beta proton and take it out and make a benzyne intermediate. Benzyne intermediate, which is benzene with one triple bond, which looks like this. Intermediate will form. Okay. Yes. Now, this OCH3 will decide where the next NH2 will attack. If NH2 minus attacks on this carbon, then I will get a negative charge here. Something like this. And if this NH2 attacks on the other carbon, I will get a negative charge near to OCH3. Something like this. It is also known as elimination followed by addition mechanism. Elimination followed by addition. Now, the inductive effect of OCH3 will decide where the negative should form. So OCH3 says I am a minus I group. I am a minus I group. I can stabilize the negative charge near to me. So this is a more stable carbon ion. This is not good. So this will not be the product. This will be the product. Ortho. So we started with a orthomethoxybenzene. Our final answer will be metamethoxyaniline. Very good. D. Kareem, here plus M you don't have to see because in benzyne the resonance will not be working. So to stabilize the negative charge, resonance will not do anything here. It has to be the inductive who will decide. Okay. So A is not correct. It is D option. Little difficult question from the NEET point of view. NEET generally does not ask benzyne mechanism, but this is also one thing you can just keep it. Next one. Which statement is wrong? Ethyl chloride on reduction with zinc copper couple alcohol gives ethane. That is correct statement. Okay, just like you do reduction with zinc HCl or you do with zinc acetic acid, you can also use zinc copper couple with ethanol. This is also a reducing agent which will reduce alkyl halides to alkanes. Reaction of methyl magnesium bromide with acetone gives butane 2-ol. Not possible, beta. Acetone is a ketone and we know ketones give tertiary alcohol. Butane 2-ol is a secondary alcohol. So when you do reaction of acetone, this is acetone. And if I react it with methyl magnesium bromide, it will give you a tertiary butyl alcohol. Like this. Alkyl halide follow the following reactivity order on reaction with alkenes. On reaction with alkenes, not reaction with alkenes, I think they want to say. Okay, this is a little wrongly written question, but alkyl iodide will always be more reactive. This is correct. Okay, not on reaction with alkene, you can, this is actually they wanted to say on reaction to prepare alkene. Means we are talking about E2 reaction, E2 elimination. So during elimination reaction or substitution reaction, always iodides are more reactive. Next one is C2H4Cl2 may exist in two isomeric forms. Let us see. C2H4Cl2, CH2, two chlorines you have to attach. So I can attach the two chlorines at number 1 and number 2. I can attach the chlorine both at first position. 1,1-dichloro and 1,2-dichloro. And none of them is optically active because I can't see any chiral carbon. So C2H4Cl2 will have two isomers only, 1,1-dichloro or 1,2-dichloro. So that is absolutely correct statement. So they are asking which is wrong statement. B is the wrong statement. Next one. It says if chloroform is left open in the air in the presence of sunlight, it gives nothing but a very dangerous gas which is phosgene. Its other name is carbonyl chloride, phosgene, COCl2, very poisonous gas. Remember this. So the reaction is chloroform, CHCl3 plus oxygen gives COCl2 plus HCl. Okay, this is the one. You can balance it by taking half oxygen here. Next one. Next question says that the decreasing order of rate of the above reaction with the nucleophiles is. Here you have to see the nucleophilicity order. Nucleophilicity order depends on how much negative charge is there on the nucleophile. Negative charge density on nucleophile. So any nucleophile which carry more negative charge will be a stronger nucleophile and show faster reaction towards SN2. Okay, so here you can see PHO minus means phenoxide. Here this O negative is going for resonance, not good, not good. Next is ACO minus, which is acetate. This is also going for resonance. This is so very, very bad. This is so very, very bad because this resonance will be a very stabilizing resonance. Okay, this resonance will be a very stabilizing resonance. We call it equivalent resonance, where the two structure look exactly the same. So it is equivalent resonance, and this is a non-equivalent resonance. So wherever you see a equivalent resonance means lone pair is very, very busy in the resonance. It will not be available for donation. Next is a OH minus. OH minus has no resonance, so that's a good thing. Then is OR minus, where the alkyl is sending also electron by plus I group. So this will be the best. So A, B, C, D, A is the worst, B is the worst, B, A, C, D, which is option C. Option C. You could also check it from their basic nature, okay? Who is the best acid out of them? Acetic acid, okay? Out of them, the best acid. Acetic acid, phenol, water, alcohol. Their conjugate acids I am checking. Out of all these acids that I just named, acetic acid, phenol, water and alcohol, best acid is acetic acid. Means worst base will be acetate. Worst base will be acetate. Bad acid is alcohol. So best base will be RO minus. This is the one. Next one. Next one asks you the pair of enantiomers, which is nothing but mirror images. Can you check here? This is the meso compound. It can't have an enantiomer. Yes, these two are the mirror images. OH was on right hand side, came to left. OH on left went to right. Second option is a enantiomeric pair. Water is stronger than acetic acid. No beta, acetic acid is a much stronger acid than water. Acetic acid is a acid. Water is not that acidic. This volume into STP volume. Okay. So this is the one. Shall we move to the next one? Shall we move on to the next one? Okay, let's see the next question now. Next question is this. Chlorobenzene reacts with chloral trichloroacetaldehyde. This is very important to give you DDT. This is the preparation of DDT. Dichloro, diphenyl, trichloro, dichloro, diphenyl, trichloro. This is the one. Dichloro, diphenyl, trichloroethane, DDT. Dichloro, diphenyl, trichloroethane, DDT, which is an insecticide. C option. Remember this, it's a very important reaction. Next question, let us go for. Let's go for the next question. Just a second, Vijay. Okay. Moving to the next one. These are few reactions given and they are asking whether it is SN1 or SN2. Beta, if any reaction is SN1, it must undergo rearrangement. So here I will get a primary carbocation. Primary carbocation should become tertiary and then the nucleophile should attach if it was SN1. But if I see here, final product has no rearrangement. Here also final product has no rearrangement. If there is no rearrangement, both are SN2 reaction without a doubt. C option. Okay. If they gave you the product with a rearranged, option, if they gave you a product with a rearranged option, that means it should be a SN1 reaction. If primary does not rearrange to tertiary, it has to be SN2 only. So that is the one. Next, we'll talk about the alcohols chapter. Alcohols and phenols. Alcohols and phenols. Which is a vinyl carbinol. Okay, carbinol is a name given to methanol. Methanol is called as carbinol. So vinyl carbinol means vinyl group attached to methyl alcohol. So this is vinyl attached to methyl alcohol. So this is carbinol, this is vinyl carbinol. So option 1. Option 1. Let us go for the next one. They are asking which of the following compounds can be dehydrated easily. Dehydration follow even mechanism, so you have to see carbocation stability. So if I draw carbocation here, the carbocation is going to look like this. CH3, CH2, C positive with the CH3, CH2, CH3 like this. A tertiary carbocation, very good carbocation. Next one is a secondary carbocation, which looks like this. Next one is a primary carbocation, which is nothing special about it. Next one is again a primary carbocation. Something like this it is looking like. So these are bad. This is also somewhat okay. Tertiary is the best. So A can most readily dehydrate. A can most readily dehydrate. Okay. Let's go to the next one. Next one says 2-phenylethanol may be prepared by reaction of phenyl magnesium bromide with. So let's react phenyl magnesium bromide. If I attack a phenyl minus here, if I attack a phenyl minus here, if I attack a phenyl minus here, and if I attack a phenyl minus here. So what is going to happen is, here this partial positive carbon it will attack on, so it will give you a primary alcohol, benzyl alcohol. Obviously hydrolysis is required. Here it will give you a secondary alcohol. So phenyl has attacked on a carbon which carries a OH and then a CH3. Here it will give you a tertiary alcohol giving you CH3, COH, CH3. This was acetone and here a phenyl has attacked. This is called as oxirane. In oxirane also one of the carbon you can say partial positive, oxygen partial negative. Phenyl can attack here. This bond will open up. So phenyl has attacked on a CH2, next CH2 and then a OH like this. So 2-phenyl ethanol is this one only. If I number it 1, 2, 3, so 2 carbon. So it's a ethanol with a 2-phenyl. So option D will be correct. Option D will be correct. Okay. We'll take a 5 minutes break now. It's 1.5 hours almost. We have 1 hour 10-15 minutes. So we'll take a 5 minutes break and then we'll continue with the next question. Okay. All of you can also go and drink some water and we'll then continue with the next question. देखना वहाँ पे पेन रखा है. Okay. Next one is HBr reacts with this particular alkene. This alkene looks like this. Under anhydrous condition at room temperature to give. So we are doing a addition reaction with the HBr here, which follows Markovnikov rule. But be very careful to make the best carbocation possible. So here the carbocation will be very stable next to a OCH3 group, which can give it resonance. So lone pair, nothing positive. This is a very stable carbocation. This lone pair can be donated like this. So finally then Br will attach to the middle. So CH3, CHBr, OCH3. Okay, its name will be 1-bromo-1-methoxy-ethane, which is second option. 1-bromo-1-methoxy-ethane. Moving to the next one. The question is, arrange the following in increasing order of their acidic strength. So orthocresol means a phenol with a methyl group on the second position. Salicylic acid. Salicylic acid is anyways a better, as the name itself is acid. It's a carboxylic acid. So don't even check phenolic group. This is a much better acid because it's a carboxylic acid as compared to a phenol. This is the best, without a doubt. It will be much better. Then just a phenol. So when we compare phenol and cresol, in cresol there is plus hyperconjugation and plus I effect of methyl, which will make it a bad acid, and this will be somewhat better than the cresol. So option will be A is the worst and B is the best. D option. Yes, just one correct. Okay. Moving to the next one, orthoxylene reacting with HNO3. Orthoxylene. Xylene means what? Two methyl groups, ortho to each other. Reacts with HNO3. It will just do oxidation. The oxidation will produce carboxylic acid. So here also carboxylic acid. Here also carboxylic acid. This is called as phthalic acid. Phthalic acid reacts with phenol in H2SO4. So first phthalic acid will undergo dehydration, giving you phthalic anhydride. And remember, when phthalic anhydride reacts with phenol, you get your indicator, which is phenolphthalein. Phenolphthalein. Important reaction as well. So how to react here? Take 2 phenol and then remove water from the para hydrogens of phenol. So 2 protons from here, 1 oxygen from here, remove it like this. 2 phenols will hang at the bottom of phthalic anhydride. 2 phenols will hang at the bottom of phthalic anhydride, something like this. This is phthalic anhydride. Here 1 phenol will hang like this, and 1 phenol will hang like this. Because practical chemistry is there in your syllabus, so you should know the structure of phenol as well. This is the structure of phenolphthalein, sorry. So this is phenolphthalein. It is pink in basic medium. It is colorless in acidic medium. It is used as a acid-base indicator whenever you are doing a titration using a strong base. Moving to the next one. This is not very important, not there in the NEET, NCERT. The reaction with periodic acid, HiO4, you can leave it as well. Okay. Next, moving to the carbonyls. That means aldehyde ketones, aldehydes and ketones chapter. Aldehydes and ketones. Very important chapter from the named reaction point of view. Remember all the named reaction which are there inside it, like Etard reaction, like Rosenmund reduction reaction, okay, like Stephens reduction. All these are there in this chapter. Many named reaction are there. You have to learn all of them. Okay. Let us start. What is the IUPAC name of this particular compound? Aldehyde is the main functional group, but I told you in the previous class also that whenever a CHO is attached to a ring directly, you should use the special suffix carbaldehyde. So it's number 1, this is number 2, this is number 4. So 2-methyl-4-hydroxy and 1-pe carbaldehyde. So 4-hydroxy, 2-methyl-benzaldehyde. This is correct. Benzaldehyde could also be called as benzene carbaldehyde. Here the benzene is missing, otherwise this is also correct. 4-hydroxy 2-methyl-benzene carbaldehyde. So benzaldehyde could also be called as benzene carbaldehyde. Both are correct. Benzaldehyde is also accepted by tic-tac, tic-for-tac, CNL. Yes, inorganic questions will be done on Monday's class. So you should log in for that as well. C is the answer here, okay, not D. C is the answer. There is no benzene in the D option. Next one is a very good question. Again, a named reaction. Whenever you take a KOH with an aldehyde, it will either be aldol condensation if alpha hydrogens are present. If alpha hydrogens are not present, it will be Cannizzaro reaction. This is a Cannizzaro reaction. Cannizzaro's is a self-reduction oxidation. So you are going to get an oxidized part which is benzoate, potassium benzoate. Chlorine will remain as it is. And you will get a reduced part which is benzyl alcohol. Chlorine will remain as it is. Do not touch the chlorine. Okay. Next one. Let us look at the next question. We are starting with a carboxylic acid. Adding PCl5 into it will make acid halide CH3COCl. OH will be replaced by Cl. Then we are reacting it with benzene. Whenever acid halide or acid anhydride react with benzene in AlCl3, it is Friedel-Crafts acylation. So I am going to get acetophenone. Acetophenone is B. Then acetophenone is reacted with a Grignard reagent. Acetophenone is a ketone. Whenever ketone reacts with Grignard, you get a tertiary alcohol. So CH2CH3 ethyl group has attacked here. What is C? So you can check what is C. Option 1 only is C. Option 1. Benzene attached to C, phenyl attached to C, C attached to OH, C2H5 and CH3, C attached to OH, C2H5 and CH3. A option. A option. Next one. Match the following. So we'll look for the best option here. Whichever reactions are there in our syllabus, accordingly we'll decide. Phthalic anhydride, I told you just 2 minutes back, it is used to prepare phenolphthalein. So B must match with 1, this option or this option. Then look at C, phenyl benzoate. Phenyl benzoate. Phenyl benzoate actually undergoes something called as Fry's rearrangement, but it is not there in the syllabus. You can leave it, no problem. Methyl salicylate is nothing but oil of wintergreen. Okay, so remember these two. When you take salicylic acid, you can do either the esterification here or you can do the esterification here. If you do esterification on the phenolic part and you make acetyl salicylic acid, this is called as aspirin. But if you do esterification at the carboxylic group COOCH3, This is called as methyl salicylate. This is oil of wintergreen. So after getting salicylic acid, how do you get salicylic acid? You get salicylic acid by Kolb's carboxylation reaction of phenol. So after that, there are two things you can do. So 1 and this matches with 3, option A. Okay. Benzoin condensation is out of syllabus, you can leave it. And Fry's rearrangement is also out of syllabus, you can leave it. So by looking at only the best particular options that you have, you can answer it. Next one. Acetaldehyde reacts with semicarbazide. What is semicarbazide? It is hydrazine attached to a CONH2. This is semicarbazide. Whenever any aldehyde reacts with any hydrazine derivative, it just undergoes a condensation reaction where water gets released like this, H2O. So you will get semicarbazone as the product, which is going to look like this, CH3, CH double bond N, NH, CO, then NH2. So CONH2 should be free at the end. CONH2 should be free at the end. B option. Okay. Next one. The next one says, which of the following compounds is most reactive towards nucleophilic addition reaction? So towards nucleophilic addition reaction, always aldehydes are more reactive than ketones because of less steric hindrance. So aldehyde में one side से alkyl group is there. In ketone, both side alkyl groups are there, which makes it very difficult for nucleophile to enter into them and attack them. So, anyways, answer cannot be this and this because they are ketone. Now, CH3 is less hindered as compared to phenyl group. So, obviously, a aliphatic aldehyde will be more reactive than a benzaldehyde because of phenyl group is very, very bulky. Phenyl group is very, very bulky. Next one. Next one says, the correct order of increasing acidic strength. Okay, acidic strength question. Let us do that. CH3COOH, I'll just draw them. Two methoxy acetic acid, OCH3 attached to CH2COOH. CF3COOH, very good. 3 minus I groups attached to second position and 2 plus I groups attached to second position. Methyl, carbon, methyl, then COH. So this is the worst. We know that electron donating group makes the carboxylic acid bad. Electron withdrawing, 3 electron withdrawing, very good. Minus I, minus I, minus I. Here there is a minus I, but only one minus I group is available. OCH3 is also minus I. So this is also good. Nothing bad about it. And this is somewhere in the middle. So best one is C, worst one is D, C, D, first option. Yes, good Jaswant. Good. Next one. Reagent which can be used to distinguish acetophenone from benzophenone. Acetophenone, which is CH3CO phenyl group. Benzophenone is phenyl CO phenyl, diphenyl ketone. So, first one is a 2,4-DNP test. Every carbonyl group gives 2,4-DNP test. So, he will also give, you can't use it. Sodium hydrogen sulfide, this is a test given by aldehydes, means aldehydes give this reaction but ketones do not. Benedict reagent is first one. Benedict reagent will not give both the test because Benedict reagent gives only test for, it's same as Felling's reagent, so it gives the test only for aliphatic aldehydes. This is iodoform test. So yes, iodoform will work. This will give iodoform test. So when I take I2 plus base, it will give CHI3 because there is a methylated ketone. This is a methylated ketone, and we know that methylated ketones give iodoform test, but this will not give any iodoform test. So D is the correct answer. It's a good question, you should remember it. Next is the second last chapter of our syllabus, amines. Amines. Let's talk about nitrogen containing compounds, amines. First is order of basic strength. Very important, basic strength. For basic strength, you have to see whether the lone pair on the nitrogen is available or is it going for a resonance. If it is available with you, if it is available on the nitrogen, that is a good base. If the lone pair goes for a walk somewhere, it is unavailable on the nitrogen, it is a bad base. So in the first one, nitrogen lone pair is going for resonance. Next one also going for resonance. And there is a NO2 is pulling him by minus M as well. So very, very bad. It is going for resonance with benzene, and then NO2 also pulls it. Here it is not going for any resonance. It is a local lone pair, localized. These are delocalized. So localized is always the best. C, A, B, third option. Beta structure, you don't have to learn all the structures. Okay. Just practice them by writing once or twice. All the structures you don't have to learn. C is the answer here. Next one. Don't try to answer fast, try to answer correctly. Which of the following reagent will convert paramethyl benzene diazonium chloride to paracresol? Okay, let us see. Paramethyl benzene diazonium chloride to paracresol. This is paracresol. So I have to just do hydrolysis here, just water plus heat. Warm water will do nucleophilic substitution here. So to convert your benzene diazonium salt to phenol, just you need to react it with warm water. Okay. Next one. Next one says, which is most basic? Again, same question. It is going for resonance and NO2 also pulling it. Not good. This is going for resonance and also it's a amide group if you see. It's a amide. Amides are very bad bases because they go for resonance with the carbon double bond oxygen, which is very good pulling group. This is the worst. This is local. It cannot go for resonance. Local is always the best. So this is most basic. This is also delocalized. This is also delocalized. So B is the best. Okay. Moving to the next one. Next one says ethyl chloride plus NaCN. Okay. Ethyl chloride plus NaCN is going to give you propane nitrile. Propane nitrile with nickel hydrogen is going to give you primary amine, propanamine. Propanamine with acidic anhydride. This is nothing but acylation or acetylation of amines will give you N-acetyl. This type of amide it will give you. So N-propyl ethanamide. N-propyl ethanamide or acetamide also you can call it as common name, which is going to be first option. Which is going to be first option. Next one. All three amines are primary, secondary, tertiary. They react with. Do they react with water? Yes. All amines are bases and they react with water. So if I take primary amine RNH2, it will react with water. It's a base, so it will take out a H plus from water, making RNH3 positive, OH negative. Do they react with alkyl halide? Yes, primary, secondary, tertiary, all will react with alkyl halide. Primary react with alkyl halide to give secondary amine, secondary to give tertiary amine, tertiary to give quaternary ammonium salt. Do they react with HCl? Yes, all of them are bases, so obviously they'll react with acid. Acetylation, primary and secondary can undergo, but tertiary cannot undergo acetylation. Okay, tertiary cannot undergo acetylation. But the last step was this only. Whenever you take any primary amine, RNH2, just like you have esterification reaction, same way for alcohols you call it esterification, and for amines we call it acylation or acetylation. So when I reacted with acetyl chloride, let's say, like this. So just remove HCl from here and make RNHCOCH3. This is acylation, just like Friedel-Crafts acylation of benzene, this is acylation of amines. So to do acylation, you need to have at least one hydrogen here. Tertiary will not react here. Here primary will react, secondary will react, tertiary will not react. So with 1, 2, 3 is the answer. Sir, once you tell the IUPAC name of amines. Beta, amines are named very normally just like alcohols. Okay. So if you have a primary amine, something like this. If you have a secondary amine, which may look like this, and you have a tertiary amine, which may look like this. Okay. So to name it, including the carbon carrying NH2, you take the longest chain. So I'll take 1, 2, 3, 4, 5. So this is pentane 2 amine. E will not be there. So pentane 2 amine, pentane amine. Here also just think, if I take this side, I can only take 2 carbons in the parent chain. Here I can take 4 carbons. So I'll take 4 carbons in the parent chain. It is 1, 2, 3, 4. It is a butane 2 amine. Butane 2 amine. And then whatever is attached to the nitrogen, just write it in the beginning. N-ethyl butane 2 amine. N-ethyl butane 2 amine. So whenever you have a primary amine, naming will be alkane amine. Whenever you have a secondary amine, naming will be N-alkyl alkane amine. Whenever you have a tertiary amine, naming will be N-alkyl alkane amine. For example, here aniline is the main functional group. So aniline will be the main parent chain. It is N-dimethyl aniline, or benzene amine also you can call it. So it is N, dimethyl aniline or benzene amine. I hope it is clear. Next one. So next question is, which of the following on reduction with LiAlH4 yields a secondary amine? Now if you want a secondary amine, you can do all the reaction. Isocyanide, methyl isocyanide, CH3, NC. Acetamide, CH3, CO, NH2. Methyl cyanide, CH3, CN, common name. It is actually ethane nitrile. Nitroethane, CH3, CH2, NO2. Yes. So whenever you take a isocyanide, it will always give you a secondary amine. This side also it will become CH3, this side also CH3. So CH3, NHCH3. Amides will give primary amine only, CH3, CH2, NH2. Nitriles will also give primary amines only. And nitro also will give primary amine. So these are all giving you primary amine. Only first one is giving you secondary amine. Okay, quickly write it down. Then we'll move on to the next one. What would be the answer for the next one? Can you tell me? Aniline reacts with oil of winter or oil of bitter almond, which is benzaldehyde. So you remember it that whenever you take aniline or any nitrogen containing compound, means ammonia derivative, and you react the ammonia derivative with any aldehyde, I told you condensation takes place where water goes out like this. Since I have taken benzaldehyde here, this is benzaldehyde, so I am going to get benzene CH double bond N, again benzene. This is called as Schiff's base. Okay, this is called as Schiff's base. Remember it only, there is no other way. In the table of NCERT, they have given this name as well. Next one. Next one says nitroalkanes with HNO2 give insoluble product in alkali, which turns blue on treatment with alkali. This is actually your one of the step of Victor-Meyer test. So when you do Victor-Meyer test, you take your primary alcohol, you take your secondary alcohol, and you take your tertiary alcohol. Then in all of them, you add reagents in order. First thing you add P plus I2. Okay. Then you add AgNO2. You will get a nitro compound. Then you add HNO2, means nitrous acid, and then you add alkali, NaOH, and observe the color. If you get a red color, RBC, you can remember RBC, red, blue, colorless. So if it was a primary nitro group, primary alcohol will give primary alkyl iodide, primary alkyl iodide will give primary nitro. If it was primary nitro, red color comes. If it was a secondary nitro, blue color comes. If it is tertiary nitro, nothing happens. So so here they are asking you blue color. Blue color means secondary nitro they are talking about. Secondary nitro, which is C option. CH3, NO2 in the middle. This is primary NO2. This will give red coloration. Primary will give red coloration. Tertiary will give colorless, no coloration. Red, blue, colorless, yes. Next one. Next question says ethyl isocyanide, means this is ethyl, this is isocyanide. Ethyl isocyanide on hydrolysis. Please remember, whenever you do hydrolysis of isocyanides, you always get methanoic acid with a primary amine. So you get a primary amine here and you get a methanoic acid here. So you get ethanoic acid, ammonium salt. Yes, ammonium salt of ethanoic acid will not be produced here. It is ethanamine with Okay, ethylamine salt and methanoic acid. So D is the correct answer. D is the correct answer. Methanoic acid will be formed. Moving to the next one. Next one, they say, indicate which nitrogen compound among the following would undergo Hofmann reaction. Hofmann bromide degradation, beta. Hofmann bromide degradation, always primary amides undergo. Any primary amide will undergo. This is a secondary amide. This is not a amide. This is a primary amide. So C is the answer. C is the answer. Only primary amides produce primary amines with one carbon lesser. And the last chapter we are going to do now is biomolecules. This chapter you are doing well in zoology as well, botany as well, whichever part of the bio you are studying it. So let's quickly revise it. They are asking which of the following monosaccharides are anomers. Beta, anomers only differ in the carbon which is anomeric carbon. This is called as anomeric carbon. Anomeric carbon, anomeric carbon. The carbon which is directly attached to the oxygen of the ring. The carbon which is directly attached to the oxygen of the ring, we call it anomeric carbon. These three carbons, this one, this one, this one, they are anomeric carbon. What are anomers? Anomers are two diastereomers whose configuration is only different at anomeric carbon. Every other carbon's configuration must remain same. Okay. OH on left, OH on left, they are not anomers. OH on left, OH on right, okay, different. Then this OH right, right, left, left, right, right. So these two are anomers, 1 and 2. 1 and 2 are anomers. Next one. The pair of compounds in which both the compounds will give Tollens reagent. Test means reducing sugar they are asking. You should remember that non-reducing sugars are sucrose and polysaccharides. Others all will give. Maltose will give, glucose will give, mannose will give, all of these. Glucose, sucrose. Sucrose will not give. Sucrose will not give. Acetophenone will not give. It's not a aldehyde. Glucose, fructose, D option. All monosaccharide sugars give you Tollens test as well as Felling's test. Which is not a true statement. Alpha carbon of amino acid is asymmetric. It is correct only. All proteins are found in L form. That is also correct. All amino acids should come here. Human body can synthesize all proteins. No. That's why we need to eat protein from outside. Our body cannot prepare the essential amino acids. Okay. Non-essential it can prepare. Essential ones have to be taken from the diet. Number of amino acids found in a protein that human body can synthesize is. Number of amino acids which body can synthesize. So these are non-essential ones. There are 10 non-essentials and 10 essentials. So our body cannot synthesize 10 and it can synthesize 10. Next one. Chemically, amylose is long chain and held by which glycosidic linkage? So they are long chain, unbranched, C1C4 glycosidic linkage. C1C4 glycosidic linkage. Okay, this is a simple question. All of you can do it easily. In a DNA, A attaches to ATGC. So A should attach to T. So T should attach to A, G to C, C to G, T to A, T to A, G to C, A to T. Like that you can easily do that. Okay. Next one. In nucleic acids, the sequence is How the nucleic acid sequence is, it is your NEET 2024 question as well. Instead of phosphate, they said phosphite or phosphorus acid. So remember it, in nucleic acids, phosphoric acid group gets attached, not phosphorus acid, phosphoric acid. So we know that here is your base, then here is your sugar, and on the fifth carbon there is a ATP or whatever phosphate group attached. Okay, phosphate. Base sugar phosphate or phosphate sugar base, anything you can say. Base sugar phosphate is mentioned here, C option. Phosphate sugar base, there is no such option as phosphate then sugar then base, so base sugar phosphate is the correct one. Base sugar phosphate. There is no attachment between phosphate and base, so this is incorrect. No attachment between base and phosphate, incorrect. No attachment between base and phosphate, incorrect. Next one, which is incorrect about peptide bond? Beta, in peptide bond, like this nitrogen undergoes resonance here. So it will become a partial double bond character. It will become a partial double bond character. Because of this, this bond length decreases. So they are saying CN bond length is longer. No, it is shorter because bond order has increased. So this is incorrect. It is a planar structure. Yes, it's planar only, that's why resonance is taking place. CN bond length is smaller, that is also correct because of resonance. So A is incorrect. A is incorrect. Moving to the next one. In amino acids, isoelectric point, how to find? You can remember the isoelectric point. It is average of the 2 pKa. pKa1 plus pKa2 by 2. pKa1 plus pKa2 by 2. You can just learn this formula if you want. So it will be 2.34 plus 9.6 by 2. Just take the average of 2 pKa given to you. Whatever this comes out to be, somewhere 12 by 2, 6 around, so 5.9. 5.9. Remember it, it is average of the 2 pKa is given. For osazone formation, effective structural unit necessary is, osazone is formed by glucose also. So you need a CHOH with a CHO, or you can take a ketone, but then there should be a primary alcohol next to it. Either of these two groups. So fructose, glucose, all of them will make the osazone. This is correct. This is not correct. This is not correct. Here also OH should have been there. This is not correct. Amino acid exists in zwitterion. This means they contain what? So in zwitterion, they contain basic NH2 group and acidic COH group. Once they replace their H, then they become zwitterion. So whenever you take a amino acid, this is how amino acid looks like. Okay. So when they exchange their proton, this proton goes here, they become their Zwitter ionic form, CO minus NH3 plus. So the reason for it to exist in the Zwitter ionic form, I have made a alanine here, is because of the basic NH2 group which acts as a proton acceptor. It will go and accept this proton. And acidic COH group. Sorry, they are asking what is present in zwitterion, okay, not in the amino acid. They exist in zwitterion form. This means they contain, in the zwitterion form, they contain basic CO minus group and acidic NH3 plus group. D is the correct one. So in the zwitterion beta, in the Zwitter ion, this is the acidic group, it contains a H plus. This is the basic group, it contains the O negative. So in amino acid, A is correct, but in Zwitter ion, D is correct. Okay. Please remember, glucose reacts with three molecules of phenylhydrazine to prepare osazone. Fructose also same. It reacts with 3 molecules of phenylhydrazine. So these are the questions I brought for you. Then there are some flow charts. If you want, I can put these flow charts in your, the description box, and then you can solve them as well. Okay. Is it clear to everybody? Is it clear to everybody? We'll keep it till here today. These flow charts I'll keep in the, description box. If you want, you can solve them. There are some questions here which you can do later. Okay, and that is all for today. Thank you very much. I hope you have enjoyed the class. Thank you. Bye bye. Take care. See you all. All the very best for your NEET exam. Meet you on Monday with the inorganic lecture. Okay. Bye bye. Thank you.